Hi, this is a short video on how to graph a square root function using an XY table. What I've done is I've got an XY table, and I'm going to find some points, the X coordinate and the Y coordinate, by putting certain numbers for X into the function here, simplifying the value under the radical, multiplying it by 2, and subtracting 3, and I'll get a Y value. And once I've got an X and a Y, I'll plot the point. So the first thing that we want to do is note that what a square root function is a function where the y value is a function of x being under the square root sign. Okay, and maybe we're adding or subtracting something from it under the root sign. But then the square root sign stops. This -3 is not under the square root sign. You do not go x plus 5 minus 3 and take the square root of that. You take the square root of x plus 5, multiply it by 2, and then subtract 3. So this is outside. So as we've talked about in class, there's a starting point for a square root function, and they generally have the same shape. It goes like this, up infinitely and curving off from that starting point. And kind of like the vertex of a parabola, that's just, we call that HK, it's actually just a little XY value of the starting point. And we can find what HK is by looking at the equation. In this case, if I rewrite this, well, the general format for this is some A value, which just represents a number, in this case 2, times X minus an H value. So when it's plus, it means it's the same as minus a -5 here. And then plus K value. Okay, and we get our H and our K, our starting point, our X coordinate and our Y coordinate there. So in this case, if I rewrite this in a subtractive format under the square root sign, it's 2 times X minus, and to make it X plus 5, it's like an X minus -5, and then minus 3 out here. And that's where you find your starting point. And most of you will just get, after a while, the pattern that when this says plus, it means a -5. When this says X minus 5, it means 5. So in this case, there's my H, there's my K. So that is the coordinates of the point that is where this sort of the launch point of the square root function, the HK. So in this case, I go from the origin to -5 and then down to -3, and that's the starting point. Okay, so now after that, I want to find a couple more points that are on this graph so that I can see kind of where it goes. I know it's going to be, the parent function goes like this. This is going to be a little steeper because that A value is greater than 1. So what I want to do is I want to find values for X that will make this a perfect square under the root sign. If you take a look at just the initial starting point of -5, -3, notice that when X is -5, this is -5 plus 5 or 0. The square root of 0 is 0. 2 times 0 is 0. And the Y value is just the -3. So now what I'm going to do is I'm going to choose a number. I want to make this a perfect square, something that has a perfect square root, such as a 1 or a 4 or a 9, etc. 16, 25. So I'm going to pick a value that makes this let's just say maybe equal to 4. So I want to know what value do I add to 5 to make a 4. So I know, oh, well, I have to add a -1. -1 plus 5 will make a 4. So that's what I want to do. So I make X 4, and I say 2 times, make it -4. 2 times the square root of -4 plus 5 minus 3. So -4 plus 5 is 1. So 2 times the square root of 1 minus 3. And the square root of 1 is 1. So this is just 2 times 1 minus 3, or 2 minus 3, which is negative 1. So that means that the ordered pair negative 4, negative 1 is on this graph. So I go 4 to the left and 1 down to get a point. Okay, so maybe now I want to choose a value for x that where I make a 9 under here. I want this to add together to be 9. So what would I have to make x in that case? Well, I'd have to make it a 4, because 4 plus 5 is 9. So I'll choose 4. You can choose whatever number you want, but if you don't choose a number that makes a perfect square, you have to get out your calculator and use your calculator, and you're going to get all kinds of wonky decimal values. So this is kind of easy. So y equals 2 times the square root of 4 plus 5, and then minus 3. So under here, 4 plus 5 is 9. So 2 times the square root of 9 minus 3. I'm just simplifying one step at a time. Square root of 9 is 3. So this is 2 times 3 minus 3, which is 2 times 3 is 6. 6 minus 3 is 3. So that means the ordered pair 4, 3 must be on the graph. So from the origin, I'm going to go 4 to the right and 1, 2, 3 up. And then I just connect those for a nice smooth curve. Okay, so that's kind of the shape, you should be expecting. If you get a point that's way out here or down here or something, you've done something wrong. Just check your computations. The other thing I wanted to do is find the domain and range. Remember, the domain is all the possible x values, and the range is all the possible y values. So if we look at the graph, I see that x never goes to the left of negative 5, does it? This graph is only visible from negative 5 and to the right on the coordinate plane. To the left of negative 5, that graph's never going to turn around and go over there. So the domain is always going to be x is greater than or equal to k, and to h, to the negative 5. Okay, so x is greater than or equal to negative 5 is the domain. It never goes to the left of negative 5. That's horizontally. The range is looking at the y values vertically. So notice this never goes below negative 3. Y is going to be greater than or equal to the k value, which is the negative 3. So y is greater than or equal to negative 3. So after you've graphed, when you look at your graph, you'll see, that it's all based on this starting point, your domain and range. So anyway, I hope that's helpful, and then take a look at the next video. It's about how to do this using a pattern that will do it quicker if you understand the pattern. So good luck.